Welcome to Rosslare Security. My name is David Bramlett. I am the Technical Support Manager for US and Canada. Today we're going to be talking about setting up a AC panel and wiring an AC panel. The first thing that we want to take a look at on setting up an AC panel, and this is the same on all of our panels, the 215, 225, 425s, is that we want to look at dip switch 1 and 2, which set our COM speed or serial speed. We recommend this to be set on 9600. You'll have your best success at 9600. Dip switch 3 tells our panel to either be one reader per door, or 2 readers per door. With the dip switch 3 in the up position, we are using 1 reader per door, meaning that if I swipe reader 1, my output is output 1. If I swipe reader 2, my output is output 2. If I move the dip switch 1 to the down position, that is telling the panel to use 2 readers per door, so whether I swipe reader 2 or reader 1, my output is output 1. Dip switches 4 through 8 are used to address the panel itself. Panel 1 would be 4 through 8 all in the down position. Panel 2 would be 8 in the up position. Panel 3 would be 7 in the up position, etc. You can find all of this documented at our website at www.axtraxng.com. That's axtraxng.com. Username and password are both the same, axtraxng. The next thing that we want to talk about in setting up a panel is that on the bottom right hand side we have an RS-232 to a 485 switch. This switch normally is in the right position on the RS-485. The only time you would put it on the RS-232 side is if you were actually hardwiring an RS-232 cable into this RS-232 connection. Otherwise, you would want to leave it to the right, and it would that would be whether you're using a serial RS-485 connection or a network connection. On the bottom right hand side we have the RS-485 connection, which is how we tie multiple panels together. We would come out of this RS-485 to the next panel and connect the RS-485 connection. Please make sure when you're using a RS-485 connection that you do use a standard RS-485 cable. Very important. Most often this is a 22 gauge cable. We do have documentations on our website as to a suggested cable. Also make sure that you're only connecting the ground or negative side in L1, L2. You don't need the positive side in that particular case. This is where we would come off of our PS33 power supply, bring our 12 volts over to power up the actual board. On the top left hand side you'll see that we have our network connection here. If we're going to go just directly to a router, we would just use a regular Cat5 cable. If you are going to connect directly from the panel to your PC, do remember that you need to have a crossover cable. When wiring our panels and wiring out to a reader, you will notice that the power is on the bottom side here, the power is on the top side. Basically, if you actually rotate them over, the wiring stays exactly the same. Also, just as a note, just to make sure everyone knows this, our connectors, all of the connectors here, you can pull them off if needed for repair or whatever it may be. You can just grab each side of this connector and pull it straight off, and that will make things a lot easier for you at times. In wiring a reader, Our reader 1 wires from the bottom up, and we have plus 12 volts, negative 12 volts. Then we have data 0 green, data 1 is white. Please make sure if you're testing and you are not opening the door, yet when you swipe your light turns, you hear your beep, and you get no events. Most often this means that we've reversed data 0, data 1, and try reversing that and see if that fixes the problem. Our next wire, the brown wire, is for LED control, which we don't use, and then we have tamper. Same exact wiring on the other side. This is our PS33 power supply, which will be in all of our panels. The PS33 power supply is powered by 16.5 volt AC transformer, 40 volt amps. This is the recommended voltage that we would put onto the panel itself. And you do want to note that when bringing this in from the wiring in, that terminal 3 is a future terminal. It's not used. And so we would wire up to 4 and 5 with our AC transformer. Often people make this mistake, go 3 and 4, and you get no power to the board or to the power supply. So just as a note. In this particular case, our locks are strikes. They are normally open, and if you are going to use our power supply to power the strike, our wiring would be from our positive side of the lock, or the red wire. We would bring it over to terminal 4, which is our plus 13.8 volts. We would bring the negative side over to our output 1 for lock 1, our normally open, and then we would run a jumper from our output 1 common over to our terminal 3, which is our negative 13.8 volts for the lock. With a strike, it is locked with no voltage to it, which is why we go normally open instead of the normally closed. When you swipe a badge, it activates the relay, closes the relay, and that gives us a complete circuit, putting 12 volts to the lock and unlocking it. A REX button, or a request exit button, wires to the input or terminal 4 and 5 of 1 and the input of 2, terminals 4 and 5. Most often you will find that a REX button is a normally open, so we do not have to worry about polarity. Either wire can be tied down. Once our system sees a short across terminals 4 and 5, it activates the output and unlocks the lock. This is also a very good little test point if you're not sure if your lock is working. If you don't have a REX, you can just short across with a wire right here. You'll see your light come on and it'll activate your lock, and that's a good way to do testing.